Welcome to today's debate on factory optimization solutions. Over recent years, we've had a lot of discussion over optimizing the process with machine-to-machine software, but the focus in the last 6 months has very much gone on to optimizing the supply of materials to the line and reducing machine downtime. Here to discuss some of these challenges, I have a very good panel of experts from most of the major players in the industry. So to my extreme right, we have Mike Zielinski from Panasonic. Welcome, Mike. To his left, we have Thomas Stetter from Mycronic. Welcome, Thomas.
Hello.
And to my left, my immediate left, of course, we have Jeff Timms from ASM, Assembly Systems, and to his left, Ken Kowarski from Hanwha Tekwin. Welcome, gentlemen. So I'm going to start off probably with you, Mike, and ask you what is your view on the current and emerging communication standards?
For us at Panasonic, we view the new standards as an additional standard, meaning we've been doing communication going all the way back through SECS-GEM. We've been communicating to third parties for the past 4 or 5 years. And so we're kind of in a wait and see mode to see if these latest standards are going to come out and be adopted by the customers. And as they get adopted by the customers, we will react accordingly. We already have a solution for communication. We got a bunch of partners already online. This is what we've already been doing. Adding another communication form will not be, it will be easy for us, and we'll do it if the customers drive us to it and it gets adopted.
Right, but if it comes in as a standard though, does that not in some way put a bit of a benchmark that stops you having to constantly be creating patches all the time for new customers?
Yeah, and if it really gets adopted to that level, yes, it will, right? Yeah. But if the customers don't adopt it 100%, it's not going to make it there. You're still going to have the company says, I'm staying on SECS-GEM. I'm going to stay here. Right. So it only becomes a standard that allows us to limit it down to 1 if the customers drive it. Not if the vendors drive it, not if anyone else drives it, is if the customers all say, yeah, this is the way we're going to communicate, then you finally achieve that. And in our talking to customers, there are some customers who are still saying, no, we've been doing SECS-GEM, we're staying SECS-GEM, we're still staying this. And in that case, we're still going to have to support all the different ones because that's what our customers are asking us to do.
Right, yeah, good point. Thomas?
We welcome at Mycronic definitely CFX and the Hermes standard. We are part of the active part of the activities here. I think it's an enabler and important foundation to really build then on digitalization and factory automation. I want to provoke a little bit. I entered the electronics world last year. Yeah. I'm coming more from the automation world, where we have standards like IPC UA, who rapidly really are now adapted by customers. So maybe we should also consider maybe not to add another standard, but maybe to look a little bit in existing standards at customers who are in automation, but also then in electronics.
Good point. Jeff?
Okay, so as I look at the need for standards, SECS-GEM is entirely different than the Hermes standard from the standpoint of complexity, and also from the standpoint, complexity is the wrong word, robustness and bandwidth, if you will, right? So if you think about the need for proper traceability, and it starts right at the receiving dock of the warehouse. You bring a reel of components in, for example, I'll just use the electronics manufacturing sector as my foundation, but you bring a reel of components in, it gets a unique ID. With the Hermes standard between machines, you can that reel of components goes on the board. You don't lose that unique ID, and everything in the traceability sector ties back to that unique ID and can be transferred from machine to machine. So the SECS-GEM is fundamentally a series of go, no-go commands. It's a series of switches, if you will, binary switches. Go, don't go, transfer, don't transfer, this kind of thing. The Hermes standard actually is a data transfer between machines. So you can do one large read. You can transfer X outs for wafers. You can transfer X outs for PCBs. You can transfer the unique IDs of boards through the line. So you never lose this unique ID. You never lose any of your traceability fundamentals. And so from that standpoint, you've got the horizontal communication of the Hermes standard, and then you've got the CFX for the vertical back to the execution systems of your factory.
Right. Yeah. I mean, as I see it, and as a layman, look from the outside looking in, you've got the Hermes on the lower level, taking packets of information from machine to machine up and down the line. But then you have CFX sitting above that. But then that also feeds in above that to your own bespoke systems that can do more sophisticated work.
That's right.
Yeah.
And frankly, the world really needs plug-and-play modules. It's like setting up your studio here for video and audio. You can buy a lot of different components from a lot of different companies, and they all plug and play.
Right. Exactly. Ken.
We have also found out when we started doing this initiative that the Internet of Things sounds like a very great idea. And we also internally have our own communication systems, but when you have to start dealing with all the manufacturers here, it makes it very difficult because we all have our own approaches. Also, one of the things we're finding out as we set standards out, they're almost becoming obsolete. Our equipment's getting better, things are changing. One of the biggest things that people would love to have happen would just be able to get their CAD program to their machines effortlessly.
Right.
But as every time we try to do that, there's CAD companies will put a new upgrade, we'll put a new upgrade, and all of a sudden that connectivity starts to get lost, and it's a lot of resources just to make sure all the CAD systems can interface with our system. And a lot of the customers are finding they don't have the resources to keep up or try to keep up with all the different standards.
Right.
So it is a challenge. For technology to work, it has to be transparent. You almost have to not know it's there to be successful.
Yeah, it's very true, and I mean, I think one of the criticisms of Camex back in the day was that it was developed, but then it was never supported or upgraded or anything like that. So, if CFX does become the standard, then it has to have continuous support and somebody taking some form of responsibility for it. Now, as I mentioned earlier, Mike, you all have your own more sophisticated systems that sit on top of this. What are the real benefits that your Panasim or INLB or whatever you've got bring to the party?
Well, one of the things that we bring is beyond just data transfer and keeping the traceability, kind of like Jeff said, for every board, every part, all the way through to the business level, is the automatic changeover. It's actually being able to go past data collection to machine control, changing a program, changing an auto width, changing the system so you can really get a fully automated line. Somebody can scan a work order at the beginning of the line or scan a barcode on the board at the beginning of the line, and the whole line automatically changes. And so it's really going beyond just data collection and data use to optimization of the process. And I think that's the one step up that we're showing through our software.
I think in a high mix environment, it's a great thing to have. Is to be able to
you can get a lot of one, right?
Right.
Because you scan this barcode, it goes down the line. Scan the next one, it goes down the line.
Yeah, excellent. Thomas.
Yeah, we at Mycronic, obviously, I mean, we are focused very much on the high mix customer segment, and we have defined our sweet spots, basically, where we want to be experts, really to provide then functional blocks on top. And of course, one of the sweet spots always have been, it's kind of our DNA, the material handling. As we also have invented the SMD towers, basically is very much where we further develop now opportunities to automate even more. Also with robotics, with AGVs and so on. I think we will come to this later a little.
Yeah, we will. Yeah. Jeff, I mean, you have some fairly elaborate systems that are built on top of this. We see one of the new concept, I think it's a concept you've got on your booth at the moment with the command center.
Yes. So as we look at the factory of today and then think ahead to the factory of tomorrow, the whole concept of reduction in manpower, increase in automation, reduction of machine assists. It becomes more and more about the workflows around the equipment than it is the equipment itself. And so if you think about where the real money is made in a manufacturing facility, everything has to deal with and address and augment the velocity of your material running through your factory. If you can increase the velocity of a customer's material moving through the factory, you increase some inventory turns. That's real money.
Yep.
Now you got their attention.
Yeah, absolutely. No, I agree. Ken.
Right, all the pick and place machines can place a part, and most of our customers know that. But if the part isn't there, you can't run your machine no matter how fast it is. And inventory management is one of the biggest sore spots with our customer. It takes a lot of time to set up a job, then you're one part short. You have to be running around your shop looking for it, you have to order it, you have to tear down your setup. And when we go in and do installs or look at factories, they want to know how can we make it better. You can always point to the inventory, the kit, the initial setup. And that's why it's so important that the machines be able to communicate back to the MRP systems accurately so they can get the proper parts to make sure they have the inventory in stock to keep the lines running. Also, auto job changeover has been one of the more effective ways of changing jobs. A lot of the manufacturers now, especially the OEMs, are laying out their boards to be one size or keeping their panels the same.
Right.
It makes it a lot easier on the operators just to scan a barcode. They know they're going to get the right job. A lot of times with all the newer systems, whether it be Aegis or iTech or any of the other systems out there, being able to do a bomb check. There's nothing worse than having the development team or the engineering team change one part and they don't find out about it. The floor is always the last to know. You build a bunch of products. So those type of things are really useful and they help, and they're very transparent in the background of the operation.
Yeah, absolutely. I mean, I think, a lot of, as I said at the beginning of the show, there's been a lot of concentration on the machine-to-machine communication initially, but that maybe you might be able to tweak the first pass yield by 1 or 2%, but where you can really make gains is in reducing machine downtime and getting materials to the line.
That's right.
So what steps are you taking in that regard specifically?
One of the biggest things is getting things integrated to everybody's MRP systems, and that's been a challenge in itself. So right now we're using more generic text files so they can integrate in. So to directly integrate into the MES systems have been a little more of a challenge. So we started doing MS SQL databases, which everybody seems to be able to interface a lot more readily. A lot of programmers for it, and our databases are now also open. And we simplified how the fields work and how that part of the database works. We separated it out a little bit from our more complex internal systems so the customers can start using their resources to access it. It's really hard from our perspective to try to look at everybody's MRP system, put the resources there to try to make it interface it and then keep up with all their software upgrades. So we're making it a little easier for the customers to be able to take our data and do what they need with it.
Right, okay. Materials management, Jeff, what are you doing to...
Yeah, so I think the key to really being successful is integration.
Yeah.
Complete seamless integration. And if you go back 5 years, for example, clearly the majority of machine or line downtime has been related to not having parts on the line, right? So what this really leads to, and you brought up the subject of control center earlier, but what this really leads to is being able to anticipate when parts are going to run out so they're already delivered to the line, and then taking the steps necessary to automate and simplify the replenishment exercise.
Right.
So they're replenished before something runs out. They're replenished in a way that it's seamless and the line never stops. So if like I said, if you go back 5 years, it was very common to have 3 or 4 people running a single line. With Control Center, our initiative there is to have one person who's quite knowledgeable directing the activity across multiple lines.
Right.
And ultimately reducing costs, improving efficiency, and keeping the lines running.
So it's reducing the number of people, but making sure you've got someone directing people to where there are issues.
Right. So there's an automatic level of direction, and then there is more of a manual oversight as well. But the total manpower required to run a factory is clearly going down.
Going down, yeah. I think a key point on that command center is that you're identifying it to make sure that the operator has got the skill set before you send them to do the job.
That's correct. Absolutely correct. Yes.
Yeah. Okay, Thomas, what are you doing on the materials management side to really try and reduce machine downtime?
Right. Basically, it's two things. First, we are doing very specific product enhancements. We have our e-labeling system basically on the reels, which is definitely helping to keep it dynamic, keep it flexible enough. We are actively in pilots with AGVs and robotics at some places to really see the entire workflow, because we really have to take a holistic picture across basically all the different steps, how to more seamless bring the materials into the line, to the kitting area and so on. And then the other thing is more process oriented, where for us in high mix, each customer is unique. And each customer basically has a unique challenge. So we, in our sales process, have a 360-degree approach. It's a more consulting approach. We really spot what are the bottlenecks also in material flow at a specific customer, and how can we really add value to this customer.
Great. Okay. Yeah, Mike. I mean, AGRs and AGVs are becoming a lot more popular for getting materials to the line. What are you doing?
We are looking into that and we are researching that, but I mean our biggest innovation for materials management is going all the way back to the scheduler. We're actually integrating a scheduler into our system, and so now you can know what work orders are going onto each line, and you're not going to be calling for parts from the warehouse automatically that are not going to exhaust in this work order. So you're actually decrementing, say you've got 100 boards left, yes, something's getting low, but it's only used once a board, it's not going to exhaust this time. I'm not going to call from that part from a tower or something else and have it sent to the floor. I'm going to know what it is. And then when you get into your final hour for the next job, it'll know in the workflow and it'll say, hey, guess what? Go call for these parts because I'm going to need them in the next hour, and because they're coming from this next work order. So being able to integrate a scheduler with those work orders basically is an enabler to bring the right parts to the floor at the time, and that's really the work that we're doing and we're showing now. We've got integrating with, it's not our scheduler, but it's a scheduler that we're integrating with basically to achieve this.
So it integrates with the inventory to make sure that all the parts are
Correct.
there before it schedules the order.
We've already had that, our material
Yeah.
control, we've already had the holding the inventory, knowing what's their allocation.
Right.
So the piece that we were missing was having that front end schedule to say what's coming up, what should be brought to the line at the time. And as the schedule dynamically changes, what we request from the warehouse and the factory and the towers changes automatically without somebody having to step in and read it. This is the rules you've already set up, and everything just flows straight from that.
Right. Okay. Now, as you know, as Jeff mentioned earlier, the trend towards reducing the amount of manpower on the line is continuing all the time. What seems to me to be the archaic part of the pick and place system is the feeder banks and the tapes and all the rest of it. Are we going to see a day when we can have an HGR or an HGV literally delivering feeder banks or some system to automate replenishing the machine?
Yeah, I mean, I think we will get there. I mean,
Yeah.
people are working on it.
Right.
I mean, these are active projects with active customers, and then there's can we get a robot to actually load a feeder? I mean, one of the things that we have is our auto load feeder, where you can just put it in and it's going to pull it through itself to reduce the time. But is there a time where you're going to set up a kit and a robot's just going to plug them all in and then that cart's going to go to the floor? Right. I think that it will happen, and work is heading in that direction. How fast, we'll see, but I can definitely say there's work being done towards that.
Yeah, I did see a concept actually almost 2 years ago now at the ACES technology days, where they had a robot plugging in a Fuji feeder bank automatically without humans. But do you think this is a future?
I agree with Mike, it's definitely a yes, but I think it will penetrate not so fast, and I think it will penetrate basically from high volume environment because it's very costly. I think for smaller customers, high mix customers, I think it's a long way in front of us. Right. It really will penetrate.
But it'll come. Long way in front of us?
Yes, well, you know, I think it's quicker. It's going to be there sooner than you think. If you look at the next or future generations of equipment and the types of things that are on the books, feeder concepts are changing, feeding concepts are changing, right? especially in very, as you said, in very high volume applications, there are bulk feeding concepts that, in fact, are in existence today that are very reliable and can hold millions of components. So how many times do you have to interact with that machine to exhaust 1.5 million components? Right, very few. The whole concept of AGVs and replenishing and automatic changeovers. Yes, it will require some level of design change and innovation in that area, but it's absolutely on the way. Absolutely going to happen.
Right. Yeah.
We feel that it's on the way, but it's going to be more of an Asian market or a tier 1 companies. Right now, we're seeing downward pressure on machine costs, and an automated guided vehicle docking cart is going to be pretty expensive. And for a small tier 2 or tier 3 company, they have to have an infrastructure. You're going to have maintenance, be able to maintain it, have battery charging stations. Somebody's going to have to program that. And if you're doing smaller volumes, it's hard enough to get to the program to the machine quickly, but now you're going to have to program your AGV to get your small amount of boards over to the machine, and it's going to cost a lot of money for the customers. And like I said, downward pressure, and do they have the infrastructure and the manpower to implement it initially? If you're a big tier 1 company, you can implement that. You do have manufacturing engineers that can start implementing it initially, but for the American market, I think we're a ways away. Automated guided vehicles have been around since 1986.
Right.
And back then, I was on a panel with Caterpillar, and they were all saying 5 to 10 years, you're going to see them in every factory. Fast forward 32 years later, and yes, they're around and in selective companies, but they're not in every 99% of the companies in the North America. You don't see them.
That's true. They're not prolific yet. That's
Right.
true, and there is a cost in that.
It's a cost. That's
some of the
why.
people that have been experimenting with it have been using fairly expensive Japanese systems for doing this, and so there needs to be more cost-effective systems for.
And a lot of our
for doing it.
customers have the perception that their AGV is going to be running off and banging into the wall and attacking their employees, or
I don't know. We've got vacuum cleaners that do it now.
Exactly.
That's right. Okay, my next question is regards feeder tape. Basically, I mean, is feeder tape really the most effective way to deliver components to the pick and place head?
no. But nobody else has been able to come up with anything better. It takes a long time to load feeders. If you have a 300 job feeder set up, you have to have a lot of people. We also have our auto loading feeder, but it's not the end all, the be all, especially with plastic type tapes, because there's so many different sizes, different manufacturers, different qualities. So it helps, and to get a feeder to load all by itself robotically has been a big challenge. For 8mm parts, we've been fairly successful. 12mm, 16, 24, it's been a struggle. And just because you may be able to do it some of the time, to be able to introduce it to the general population or the companies, it has to work every time.
Right.
20% or 60 or 70 isn't good enough. They want 98 or 99% before you can introduce it. So what that's going to be, I'm not sure. I feel that probably by the time we figure it out, electronics will change to the point we're not building boards like we are now.
Possibly, yeah, you're right. Jeff, you've done this to a limited scale with certain devices, but you're not with bulk feeders.
Right,
I'm
sure.
talking, but you don't have bulk feeders for every device, for every component. So
I think there's always going to be a place for tape. The question is how prolific is the tape, right? You've got short strips, you've got full reels. For your high runners, it can definitely go in bulk, and bulk feeding techniques are really changing. What used to be a very difficult and tedious process to bulk feed devices has changed largely because of the speed of processing. You can throw a handful of components on a glass plate, process that with an under glass camera, and then feed that information in real time back to your machine so it knows where to pick them up. And it knows which ones are upside down, which ones are right side up, which ones are on edge, which ones aren't on edge, and the orientation. So with certain devices, you can be very effective with that kind of feeding mechanism. And if you think about the green aspect of that, that's another aspect that's really important.
Right.
If we've got one customer that actually produces enough scrap tape to fill up an Olympic-sized swimming pool 3 times a year.
Absolutely. I mean, it just seems archaic. I mean, there's so much waste goes on with tapes. I mean, do you really think that's going to be the future?
I mean, we don't necessarily like it to the way it is with regard to sustainability, of course. And but I think tapes will be around even in 10 years from now for certain market segments. I think I agree. It's a differentiated picture. We're also looking into bulk, but I think customers are really cautious about contamination issues in this and the quality issues related to it. So.
Right. Okay. Mike, do you have a view?
Yeah, I think some components are going to be very good for bulk and some won't. And there's concerns with bulk about traceability, if people are dumping things, and contamination, basically, of the feeder getting dirtier over time. Those are the two biggest things in the past that have been challenges to bulk and why hasn't been implemented more. And people are coming solutions to those problems. So I think you're going to see more and more bulk, but there's always going to be tape. It's the necessary evil until something radically changes.
Radically changes, okay. Nice. Interesting perspective, so thank you for that. My final question, just to round out this panel today, is really one I've been trying to get out of you guys for quite some time. What percentage improvement can EMS companies expect by implementing a fully optimized line?
That's hard to say because it's hard to say where they came from, right?
Right.
I mean,
course.
so
It's relative,
so let's just take where can you really get single-digit DPMO? Yes. And will we start talking about a single-digit DPMO with this stuff? Yes. And so if somebody's listening to this, they know where they are with respect to that. I really believe, I mean, we currently have people at that single-digit level, the 1 to 2 consistently day in and day out. Getting them into sub is a reality in the future. So especially as we add more learning, as things start adding with artificial intelligence and other things that we're looking into to basically look at the programming, making sure there's no mistakes in that, letting things get reviewed. When you start adding all this, sub 1 DPMO will be possible in the future.
Right. Okay, good point.
First, I would say it's only one KPI for our customers. It's not the only KPI I think they're looking for. And when I mentioned the 360 degree, I think we have some cases where in high mix they're coming from 25% utilization rate, and we can ramp it up to 40 to 60%.
Right.
But it's always a range.
Okay, so you look at utilization rate.
We would rather say, yeah.
Okay.
It's very difficult for us to look at.
Okay. Jeff.
Yeah, so I agree with what both of these gentlemen have said, and certainly we have customers that are sub single-digit DPMO, but it is only one of the KPIs of the factory, and I think that if once again it comes back to having a seamless and integrated solution that supports itself, supports your process, supports your product, supports your factory. So if we think about the utilization levels, machines don't break down like they used to, right? Machines just run anymore, right?
Yeah.
So how do I make sure my solder is correct? How do I, most of the defects are really caused by solder paste.
Yeah.
How do I make sure my solder paste is correct? What are the intelligent systems that we're going to use to control that? What are the methodologies that we're going to use to replenish the line? What are the methodologies we're going to use to change over the line? And this is a very important point. How are we going to return material to stock in a way that when we pull it again, we know exactly what we have and it's not mislabeled, right? So all your count backs and all of this type of stuff. All of these things lead to potential problems on the floor. So what you end up with is a series of test points that become seamlessly integrated with each step in your manufacturing process, and they're invisible to the operator.
Yeah.
But the machine will say, I've got a problem, I'm either going to fix it myself or I'm going to stop and have somebody fix it. But it's got to start right there.
Okay. Ken?
When we find we're going to integrate one of our factory systems, And we will see sometimes a 30% increase. But when you look at how that happened and start breaking that down, we find that as they're preparing to use our integrated system, they're starting to clean up their initial processes. And so they're seeing a lot of gain because we're forcing them into a system and forcing them to have better habits.
Right.
And the system does help. But what also we're finding out is we have every piece of data imaginable that we can output from our machines, but our customers are going into data overload. They can't manage all this data. It's really a great thing to find out the machine was stopped, but if you have 30 lines of machines stopping 10 times a day, you just have a long list, and it's really hard for them to manage it. A lot of times I see and we even do this, we have this guy sitting in this control panel with all these monitors around him, monitoring the whole world. And what we're sitting there, what is he actually doing? Is he just looking at them? Is he able to interface with them or call everybody up and say, hey, you're down? So it's you got to be careful in the North American market to give what they need, not what they ask for.
Well, yeah, I mean, I think that's coming into the data argument. I think there's so much data coming out now. It's hard to manage it. But if you listen to Cisco, for example, they say what data. You ask them what data should you be collecting. They say collect everything, because you don't know what you're going to need 6 months down the road. The bottleneck is interpreting that data to be able to make actionable decisions at the end. That is true, and the volume of data that's coming out is almost getting to the point that at some point soon we're going to need AI to boil it down a bit. Yeah, that is a challenge going
That's
forward.
what we're looking at, skipping smart factory and moving right into AI. Because they're going to have to be able to have something to interpret that data so you can react to it properly.
Yeah, exactly. Yep.
Actually, when you look at the whole subject of AI, it is something that has to be managed today very carefully. Big data and the subject of analytics is actually a fast emerging field. And I don't know if you saw about 2 months ago we did a grand opening of an R&D center in Taiwan with over 100 engineers doing nothing but analytics and Internet of Things.
Okay.
Right. So, but it's got to be taken very seriously because, and I agree with the Cisco, collect everything and look for the correlations.
Yeah.
But you without having that, you won't see the trends.
Exactly. I totally agree. Well, gentlemen, I think we've had a fantastic debate today. Lots of really quality input. I want to thank you all for taking part. So we've got Mike Slinsky from Panasonic. Thank you, Mike. Thomas Stetter from Micronic. Jeff Timms from ASM Assembly Systems, and of course Ken Kowarski from Hanwha Teklin. Okay, and thank you for joining.